Okay, we're good to start. All right, so in today's session, in this evening session, we're going to look at the second part of vectors. So this is the last part for vectors. In lesson 1, we did an introduction and we're also given an assignment. And now we're going to set it off with this session. So as you have noticed, vectors is also one of those simple subjects, simple topics. You can actually get to figure out and make sure you get all the marks. Yeah, so this one is going to have an additional question as compared to what we looked at the other time. Plus also, like I mentioned in the other session, we're going to also have scenarios where they express vectors in terms of ratios. So that is basically the only new thing about this particular session. So our first example, as always, is coming from an exam paper, which in this case is 2024 paper 2 GCE. And the question says, in the following diagram, OA, vector OA is equal to vector A, vector OB is equal to B, and AX to the ratio AB is this ratio here. AX to AB is given that ratio. Okay, so where is AX and where is XB? So this is A and this is X. Okay, and then this is X and this is that is B. So what does that ratio mean? What it simply means is that from A to X we have a 2, okay? And then you notice here from X to B we have a 3, okay? So AX is the first value they give you, okay? And then wait a minute, it's AX to AB. AB is this distance from there to there, okay? So AX, here we have a 2, okay? And then from there to here, the total is a 3, okay? So the last value they give you is simply the total for the entire line. Let's say you have another example. You have this line, let's say this is point A, this is point B, and this is point C. Let's say they've told us to say the ratio AB. I want you to understand this because it's very important. Okay, AB to AC is given the ratio maybe 1 to 2. Okay, that will simply mean that the distance from A to B is represented by a 1, and then the distance from A to C, the last value is, notice A to C, that is the last value there. So meaning the distance from there to there is represented by 2. So meaning the total for that particular line is a 2. So for it to be a 2, meaning even here it's going to be a 1. So that when you add 1 plus 1 there, it's going to give you the 2 there. Let me give you a different example. This one is quite simple. Let's use different fractions. So let's say the ratio, they're using the same values, but the ratio is maybe 2 to 4, okay? 2, okay, let's use different values. 2 to 3, okay? 2 to 3 is supposed to be a full colon, okay? So, and then we have a line, which is, there's A here, and then there's B there, then there's C there, okay? So, A to B is represented by this value, the first one they give you. So, meaning here you have a 2, from A to B, okay? And then the last value on your ratio here, this 3 represents the total for the entire line, meaning from A to C, the total is supposed to be what? It's supposed to be 3, the distance from there to there, okay? So, if from here, from A to B here, it is a 2, and the total for that line is a 3. So, how do you find this guy right there? You simply say 3 minus 2. So, meaning the distance from B to C is basically a 1. Alright, I hope that is clear. The total is supposed to be a 3, and then they'll give you one region. So, you may be able to find the other region by simply subtracting the last number from the first number from the last number. I think that is the simplest way I can simply explain it. Okay, so now coming to our question. Okay, they have given us a ratio for one of the vectors. Okay, let us investigate the question. So the question says AX, okay, AX is given the ratio AX to AB is that ratio. So let's write it down. AX to AB is equal to 2 to 3. Okay, so remember we said the first distance they give you is represented by the first number. So from A to X we have a 2 there. Okay, and then the entire line, okay, which is AB. You've noticed here they've given us AB. So meaning A, B is represented by the last value here. Okay, so meaning the total for this line is supposed to be a 3. So you need to find this distance here, which is A, XB. Okay, XB. How do you find XB? You simply subtract the last number from the first number from the last number. So it's going to be 3 minus 2 to find this distance right there. Okay, so that's going to give us a what? A 1. Alright, such that when we add both of them, okay, 2 plus a 1, they give us the total for the entire line, which is a 3. Is that clear for the ratios? If it's clear, please respond with a thumbs up. I'll continue explaining as we even get to the next question, because this is the only part remaining for vectors. Okay, this is the first part remaining. The last one is basically when they give you a question and then they ask you to solve in such a way that your solution leads to the answer they give you. So that is how you interpret ratios. Okay, having done that, we can now go to the question. So the question, like in the previous session, the first one is always simple. Okay, express in terms of vector A and or vector B, the vector AB. So remember we said for vectors always use a known path. Okay, a path with given values. So we're trying to move from A to B. What is the best way we can move from A to B? Okay, so this is a 1. The best way we can move from A to B, of course we can move from A direct to B, but we don't know these values yet. We just know the ratio here. Okay, so meaning the best way is to go in this direction to O first, and then from O we come down towards to B. Therefore, having moved from A to B, so meaning our vector AB will be represented as, okay, AO, vector AO. So I'm moving towards to O at this point, and then from O we move down to what? To B. Okay, so AO plus OB, that will give us what we are trying to achieve, and that is to move from vector A, from point A to point B. So now we're going to say vector AB will be equal to, what is vector AO? What is the value represented by vector AO? The value is vector A there, and you notice the vector is heading in this direction. You notice there the arrow, okay, but we are heading in the opposite direction. Therefore the vector becomes a negative. So meaning AO becomes negative vector A, like that. We bring down the plus. What is a vector OB? So vector OB, we're going downwards like this. The vector is heading in our direction. So at this point we're going to capture the positive value for that particular vector, which is simply a B. Okay, you can see it's almost the same as what we are dealing with last time. For the first question, there isn't much you need to do. You simply need to rearrange the values there. Make sure you indicate the underlines for each value to show that this is a vector, and you are done. Okay, that is our A. We have captured that one mark. We come to the next one. We're trying to find XB. Okay, so how can you find XB? So XB is basically moving from that one to that one. Okay, so now how do we actually move from that one to that one? So what is the ratio? So let me also explain something which we are going to be using to now interpret these values. Okay, let me just create space here so that I can do it from up here. Okay, maybe we need AB at some point. I don't think so, but let's just record it somewhere in case we need it in one of these questions. So that is B minus A, B minus vector A. So I want to explain something up here. So let me just create some space. All right, okay, so now what is going to be your ratio for this point. So just as we are doing the time we're looking at those ones for the midpoint, where they give you to say one of the vectors like in a line, then they say this value is the midpoint of this line and all that, and how we get to interpret to say this is going to be half of the entire line. So here we're going to be using the values. So vector A, vector AX. Please mute your mics. I'm hearing some feedback. Okay, so AX, how are we going to represent that particular vector? So what is the value for AX? It is a 2. Okay, so it's going to be 2. Let me write it here like this. Vector AX will be equal to 2 over the total. What is the total? The total for the entire line. Remember we said the total is what? AB is 3. So it's going to be 2 over 3 of what line? Okay, what is the total for that particular line? So you go back to this one up to that one, which is AB. That's the same as what we are doing in the first station. So that's how we're going to represent AX. If you come to XB, so we're going to say XB is going to be expressed this way. So XB will be equal to, what is the value for XB? It is a 1. So 1 over the total again. What is the total for this entire line? This one right there, AB. The total is supposed to be 3, remember that? So it's going to be 1 over 3 of what line? The line is AB. Okay, what this particular line is extracted from, it is AB. So 1 over 3 of vector AB. That is how we're going to express it. Alright, so now we have already expressed XB the way it needs to be expressed. So now we just need to plug in the value for AB. What is AB? We found AB right there as what? B minus A. So we're going to say XB, vector XB will be equal to 1 over 3 in brackets. We're going to say B, vector B minus vector A, and that is our final answer. We are done. Okay, there's no need for us to solve any further than this. I feel like I should give you another example for expressing these fractions when it's part of a line. So let me just draft up another example. I want everyone to be able to solve this question. No excuses. Okay, so let me just clear some space here so that I can give you another example. So let's use one of those examples we used for a line. Let's say this is J, we have a K there, and then we have an L there. Okay, and we're told to say JK to KL. The vector is represented by, let's say, is equal to 2 to 3. Okay, so what does that mean? The distance JK is represented by that value. So meaning here we have a 2. Okay, then KL is the entire line. No, this is supposed to be J, not K. It's supposed to be J. Okay, yeah, so JL is the entire line represented by the last value. So meaning the total from J to L must be a what? Must be a 3. So meaning what is the distance here for KL? This distance right here. Okay, we are just going to be say 3 minus these 2, giving us a 1 for this one, so that when we add 1 plus 2 we get the total for the entire line, which is a 3. Okay, by this point I think we should all be good at plugging in these values into we should be able to interpret the ratios. So at this point now, how do you express JK? Okay, which is what we're from doing on this question. So how are we going to express JK? So JK is represented by what? 2. So you write your 2 over the total for that entire line. What is JL? Okay, what is the distance for JL? Remember we said the distance is represented by the last value. So the total is going to be what? A 3. Okay, 2 over 3 of what vector? Okay, so now we are going to capture the entire line, the one represented by the total, which is JL. So you put your JL like that as a vector. You come to the last example, which is KL. How are you going to represent KL? So you're going to say KL is equal to, what is the distance for KL? It is a 1. So we're going to say 1 over, what is the total? The total is still going the same as this one. The total is a 3. Okay, so now this is a fraction of which line? The entire line, which is going to be this one, which is JL. So same thing again, vector JL. So that is basically how you express these ratios for the parts of a line or a vector. I hope that is making sense. We now go to the last example. Let me just clear up right here. Don't want to leave people hanging, so that's why I'm laboring to ensure that I try as much as possible to explain these concepts the simplest way I can possibly explain them. Okay, we now go to the second last question, which is asking us to find. So we have found, just pick up my pen inside. Okay, so we have found xb. We now need to find xo. So what is xo? So we're moving from x to o. Okay, so how can you move from x to o? Okay, for us to move from x to o, okay, we need, since we are going to need xb here. So what did you find as the value for vector xb? Let me just see. So we said xb is of the ratio 1 to what? 1 to 3 of the vector ab, which is this one here. So in brackets we're going to have b minus a. This is the answer we found as the vector for xb. So now here we're asked to find xo. Okay, xo. So how can you move from x to o? We know vector xb. Okay, xb, we know this vector, right? So for us to move from x to o, we can say xb plus bo, right? We can move from x to b, and then from b we move to o, thereby achieving this vector, which is xo. So we're going to say xo is equal to xb, vector xb plus vector bo, right? Okay, our goal is to move from here to there, but we don't know the vector for that guy, so we're going to instead come down here and then we go in that direction. So that's xb plus bo. All right, so now what is the value for xb? Okay, xb, we found this one right there, 1 over 3. So it's going to be xo will be equal to xb. We found 1 over 3 in brackets. We say it's vector b minus vector a, close bracket, plus what is bo? So bo is represented by this value. This is actually ob when you're heading in this direction. So meaning bo, we are heading in this direction from b to o. Okay, so it's therefore going to be a negative vector b, because we're heading in the opposite direction of that particular vector. Going downwards like this, it's a positive. Okay, since we're going against the direction of the vector, it therefore becomes a negative b. So you can then simplify by saying vector xo will be equal to, so you can expand here, 1, so the 1 multiplies with all the values inside the bracket. Okay, so that's just going to give us that is 1 over 3 vector b, okay, minus 1 over 3 vector a. Okay, 1 times b is a b there, 1 times negative a is negative 1a there, just like that. Okay, and then here we're going to multiply the signs. Positive times negative there gives us negative vector b. So we can group the like terms. We're now going to say vector xo is going to be equal to 1 over a 3 vector b is going to be grouped with that guy there. So negative vector b over a 1 there for the negative b, so that we come up with a common denominator. By now we are okay with these values. We did a lot of these solutions in lesson 1. Okay, so once we've done that, we can divide. 3 divided by 3 there is 1. 1 times 1 vector b is just going to be vector b. Bring down that sign. Okay, and then we're going to say again 3 divided by the one there, so 3 divided by this one, it's a 3 times vector b, that's 3 vector b, and then we say minus 1 over 3 vector a. Just bring down that guy there, then we simplify up there, vector b minus 3 vector b, that's just going to be negative 2 vector b. So if you want, you can simply refer to them as fractions, as algebraic fractions, in case the vector part might confuse you. Just say b minus negative 3b, but just remember to underline the vector there. Okay, then here you notice to say we can actually simplify. We can so this would be our answer here for vector xo. But remember, we said in the first session that you can actually factorize vectors. Okay, so what is common for the numerators there? What is common there is a negative 1. All right, negative 1 is common. What is common for the denominators? It is positive 3. So you can actually factorize. So negative 2b divided by negative 1 to give us negative what? Positive 2 vector b, like that. Okay, then the 3 there divided by this 3 here will give you a 1. Okay, and then this negative divided by that negative there give you a positive 1 over 3 divided by 1 over 3, everything will be cancelled. You just remain with that guy there, and that will be our final answer. Okay, do you have any questions at this point before we proceed to the new question? Okay, I don't see any question. We can proceed to the last question on this particular example. So just clean up. Okay, so the last example, the last question is saying, given also that, just change my to a pen. Okay, given also that OY, okay, vector OY, let me just scroll up a little so that you can be able to see the diagram. Okay, and let me clean up also. So what they are saying is that OY is equal to 3 times OX. Remember, in the first session we looked at scalar quantities. Okay, OY, this is O, and this one here is AY. Okay, OY is 3 times vector OX. Okay, let us write that down. OY, vector OY is equal to 3 times vector OX. Okay, we actually found OX and I've raised it. That was I think that was negative 1 over 3 open bracket 2 vector B plus vector A. Okay, that was our answer for OY. Let's see, can I redo? Okay, I can redo. So let me just undo. I see the answer for OY. I confirm so that I don't mislead anyone before I deleted everything. Okay, looks like I cannot undo all the way to that point. Yeah, but I think that was correct. Negative 1 over 3, and in the brackets we had these vectors here. Okay, so what to say, given that OY, is my pen selected? Okay, given that OY is equal to this expression up here. Okay, what they're asking us to find now is to show that when you solve for BY, the solution for vector BY, where is Y? BY up to this point, the final answer you're going to get is that one. That's what they're asking us to show. So what we're going to do first is find the value for OY. How to find the value for OY? You're going to say OY is equal to 3 times OX. So you might remember, this is what? This is XO. This one we found here. So to make it OX, we're simply going to multiply throughout by a negative. So it's just going to be open bracket negative, okay, times, so let me use a square bracket right there, the vector itself, 1 over a 3, okay, then in brackets again you're going to have 2 vector b plus vector a, you close, and again you close. Okay, so what we found was XO. For us, when we switch the values to find OX, it simply means the vector now becomes a negative. So you notice here they are asking us to say what is XO right there. Okay, we found OX, we found XO, and now they're asking us to find OX. So simply make this vector a negative. So that's how come we're multiplying with the negative right there. Alright, so meaning our XO, it's actually OX. What we found is XO. So meaning our OX will be equal to, we're going to multiply this sign with that sign there to make it a positive. So it's going to be 3, open bracket, 1 over a 3, okay, open bracket again, 2 vector b plus vector a. Then we can simply expand to find the actual value for OX. So this is 3 times 1 over 3 times, okay, then in brackets. So here we can actually put brackets, so that the 1 over 3 is multiplying with everything inside the brackets, okay, plus a. So here meaning these guys can cancel. So I can simply say this and that will cancel. So what do you remain with? We're just going to initially remain with the brackets where we have these vectors, because it's going to be 1 times 2 vector b plus a. So meaning the actual value for OX will simply be equal to 2 vector b plus vector a. Alright, so now having found OX, we can now go to our question, which is asking us to find by. So how can you move from b to y? So to move from b to y, we can actually move from b to o, and then from o to y, because we have found by. We have been told to say oy is equal to 3 times vector ox. So this is actually the final answer here, is actually oy. Okay, I've spoken about a lot of things here. I hope I have not lost someone. So let me just explain what we have done so that people follow closely. Okay, so we're told to say, the first thing we're told to say is that vector oy is equal to 3 times vector ox. Okay, in the question here we found xo. So to convert it to ox, which is what they're asking for here. Okay, let me just label it here. So in the question, the first question we answered was, we found xo. So now we need to find ox. So what do? We simply multiply it with a negative to make it, okay, to make it so xo, when you change the values, when you change the lettering, you swap them, okay, the o comes in front. So notice here the o is at the back, here it has come in front, the x was at the front, it has come at the back. When you swap these values like this, it simply means it's almost like you're heading in the opposite direction of the original vector, so it becomes a negative. All right, so now this was our xo. On the far left of the screen, you can see this one here. This was our xo. So we got our xo, we brought it there, okay, and then we had to, since it's becoming a negative vector, this is the negative you are seeing here, multiplying with the entirety of what? xo. After we multiplied everything, it led us here. Okay, this whole expression we are solving was basically for what? Oy. So meaning our oy is this answer here. Okay, so at this point we can now be able to find the vector by. So to move from b to y, we are going to use the known values. Remember, we don't know what by is. We don't know the value for this vector. So the only option is for us to go to O, and then from O we come down to OY, because we know OY right there. We're just from finding it. So that's how we're going to move. So we're going to say, to find by, we're going to go to BO, okay, plus OY, vector OY. We go from B to O, and then we go all the way from O down to by. Therefore, we would have moved from B to Y. Okay, so now what is the value for BO? Okay, the value for BO is this one right there. Okay, the direction of the vector is this one. It's going in this direction, and we are heading in the opposite direction, meaning it's going to be negative what? Negative B. So we're going to say vector by will therefore be equal to negative vector B plus 2 vector B plus A. And then when we simplify those values, we're going to say vector by will be equal to, so negative B plus 2B, that will give us positive B. Okay, plus vector A. So now if you look at our answer here, it is starting with A. So all we have to do is we simply rearrange those terms to make sure that our final answer also starts with what? With vector A. And therefore, we can simply say, hence shown. Okay, that is your final answer. So this question can be a bit tricky because there's a way they want you to solve it, such that when you solve it, it should lead you to the answer they give you. Okay, for this one, it wasn't that tricky. It was quite simple because there wasn't much to be done. The other questions will require you to start factorizing. Okay, and the type of factorization you're going to be doing is a bit different from what we're used to. All right, so as you have noticed, we have solved the value for by, and it has led us to the exact answer the examiners gave us. That therefore makes our solution correct. Do we have any questions at this point? I can expect questions here because this question is a bit involving. Do we have any questions? Okay, is it making sense? If it's making sense, give me a thumbs up. Is it making sense? Or people still need another example to determine whether it's making sense or not? Okay, so I've seen a question in the chat. Let me just have a look at it. Okay, since XO has a negative already, meaning it's in the opposite direction. XO is equal to negative 1/3. Okay, so the final answer, the negative on the final answer doesn't necessarily mean that the vector is a negative. Okay, what determines that the vector is a negative is basically the direction of that particular vector. If you remember, some of these answers we keep finding that the final answer has a negative value. It's starting with a negative value, and then you simply rearrange the values to make it start with a positive value. Yeah, so that is basically the idea. So despite the fact that it starts with a negative, it doesn't necessarily mean that the vector is a negative. Yeah, so only when you switch them around. So for these types of vectors, you notice to say the direction is not indicated, so implying that the first one they ask you, that is basically the direction for that particular vector. And then when you switch them around, so if XO, for example, XO, the final answer for XO is positive 3 vector B, meaning if you now change from XO to OX, it becomes negative 3 vector B. So that's basically that. I don't know if that is clear. Okay. All right. Okay, let's proceed to the next example. So please follow me closely. I need you to be able to earn all these marks. You're not supposed to leave out anything. Okay, we come to another guy. So this one is coming from 2024 paper 2. This one was written by the grade 12s in 2024. And it says, in the diagram, EFG is a triangle in which vector EH, okay, vector EH. So E is right there, H is right there. Vector EH is equal to 4 vector A, okay? And we're told to say EF, vector EF is equal to 4 vector B. EF, E is there, F is there. Okay, so equals to 4 vector B. And we're told to say the ratio for F to J, FJ to JG is 1 to 3. So let us do our thing again. Okay, FJ to JG is given the ratio 1 to 3. So meaning the distance FJ is equal to what? 1. So where is FJ? FJ is there. What kind of a one is this one? Okay, so I have a 1 there. Okay, and then JG. JG, in this case, is this distance from there to there. Alright, so here again the examiners have changed the ratio. Alright, so meaning the distance from J to G is equal to what? Is equal to 3. Remember in the previous question, they would give us something like this, but then the second part of the ratio would represent the entire line, meaning it would be FG. But here they have changed, they are saying JG. So it simply means this distance is equal to that one there, and then this one is equal to that one. So to find the total, you have to add these values, okay? 1 plus 2, giving you a 4 for the entire line. Because you notice to say, from F to J, it is a 1, okay? And then from J to G, it is a 3. Meaning the total for that line is going to be 3 plus 1, giving you a 4. Alright? So that is that. And H is the midpoint of EG. H, where is H? So H is right there. It is the midpoint of EG. Okay? EG. If it is a middle point, meaning what you have there is what you should also have right there. So meaning even here we're going to have 4 vector A. Okay? That is what that means. Okay? Since H is at the center, meaning what you have there is what you should also have there, since it's at the center. So the next question then says, express in terms of A and O, vector B, the vector FH. So I'm going to say FH, vector FH. What is the vector? Vector FH will be equal to, so how do you move from F to H? So F is there, H is right there. So you can move from F to E, and then from E to H. Okay? So I'm going to say FE, vector FE, plus vector EH. Then we plug in the actual values for those vectors. So what is FE? FE is heading against the direction of the vector, so it's going to become negative 4 vector B. Negative 4 vector B. This one right there. Okay? When you're heading in this direction, it's a positive 4. When you're heading against the direction is indicated there, it becomes negative 4 vector B. And then EH, okay, we're heading in the same direction as a vector, so it's just going to be positive 4 vector A. Again here we simply rearrange. Okay, FH. So you've noticed here, Mr. Mape, notice this is the final answer for vector FH. But just because it starts with a negative, it doesn't mean that is the negative vector. No wonder we say it's actually recommended that you rearrange your values so that the final answer starts with a positive term. So meaning when we rearrange again here, you will notice to say you can still factorize this vector because there is a common factor. So initially, if as we solve this question, we need to use this question, we're going to capture that answer. This is the answer we're going to use, the expanded one. Okay, but for the sake of simplifying things here, we're going to factorize with a 4 because a 4 is common here. So 4a divided by 4 is going to give us an a. negative 4b divided by 4 give us negative vector b, and you are done. But if we need to use this particular answer, we're not going to go for the factorized answer, we're going to capture this expanded one. Because if we capture the factorized one, it simply means we need to start expanding again to solve the question. Alright, we now go to the next example, which is saying find fg. So how do you find fg? So f is there, g is right there. Okay, so we're going to say, so to move from f to g, remember these values, okay, we can't use these values yet because we need to find fg. So to find fg, we're going to go from this direction to that one, so from f to e, and then from e all the way to what? To g. So if it is 4a here and it is 4a here, meaning the total for eg is going to be 8 vector a. All right, so that is the value for eg. So let us plug in those vectors. So we're going to move from f to vector e, so that is b. To find fg, we're going to move from f to e, f to vector e, vector fe, plus, and then we move from e all the way to g, right? So e, g, like that. Then we plug in the actual values for those vectors. So what is fe? Fe, remember again, we're heading against the direction of the vector. The vector is heading in this direction. As you can see, it is indicated right next to the value for the vector. So it becomes a negative 4 vector b as the value for fe. Then eg, we said the total for eg is 8a. Because we have 4a there and 4a there, when you add them, we're going to get positive 8 vector a. Why? Because we're heading in the same direction as the vector. You can see here the vector is heading in the same direction as we are heading. So at this point again, we're going to rearrange the values to ensure that the answer starts with a positive term. So vector 8a minus 4 vector b, and then again you can see that we can actually factorize this vector. Otherwise, this would be our final answer if we're going to use this question somewhere. So meaning we're going to say, what is the common factor for the coefficients there? It is a 4. So we're going to say 4 into 8 gives us 2 vector a. Negative divided by positive for the 4 there, it's a negative. 4b divided by 4, it's just going to give us vector b. So this will be our factorized answer. So if the answer you have found can be factorized, always factorize, just to be safe. You don't want the examiner to remove some marks from your answer simply because you couldn't factorize when you actually know how to factorize. So please don't leave any leave out anything that you know you might need to do. Okay, we come to the last one, which is asking us to find vector ej. Okay, vector ej, let us identify the vector. So I'm moving from e to j. How can you move from e to j? There's a known route here. We can go in that direction and then we can find fj. Remember, for us to use these values determined by the ratio, we need to know the vector for the entire line. So the entire line is what? Fg, which is what we're from finding right there. So we can therefore use this ratio here for Fj. In order for us to move from E to J, we're going to move from E to F, and then from F, finally, we land on J. So let us write that expression down. So we're going to say C is equal to Ej will be equal to, so we're going to move from E to F first. So we're going to say EF plus, then we are going to move from F to J. So plus Fj. So Ej, vector Ej will be equal to, what is EF? EF is basically this value there, heading in the same direction as the vector, therefore it's going to be a positive, plus what is Fj? Okay, so remember there's a fraction right there. Fj is represented by a 1, over what is the total? We're going to say 1 plus the 3 there, giving us a 4 of what vector? Okay, this fraction is part of, this line is part of which main line? So we have fg there, so fg. So that is how we're going to express our fj, and then there we're going to plug in fg. So just from finding fg, so all these questions are strategically placed. They'll ask you to find something they know you need to use later on. Okay, so for vector b plus 1 over f4, and then in brackets we plug in vector fg. So fg, we found it is right there. Okay, so it is 4, allow me to use a square bracket here. So it is 4 open bracket 2 vector a minus vector b. Okay, let us scroll down a little. So remember, this is multiplication, so we can actually cancel out these 4s, so that we are just going to remain with ej, like I explained in the other example. It's going to be 4 vector b, we just remain with a 1. So 1 times everything there to just give us everything in the brackets, 2a minus vector b, then you can group the like terms. So we're going to say vector ej will be equal to 4 vector b minus vector b plus 2 vector a. Alright, so ej, vector ej, be equal to, what is 4b minus b? That will give us 3b. Okay, 3 vector b, and then plus 2 vector a. And this will be our final answer. Okay, do you have any questions before the end of Chara's fight? Do you have any question? Okay, so could be mafunzo and the Chara's fight match. Right, let me just clear up some space here. Before I clear, let me see, what do we need? Okay, fp, we need to find fp is equal to fh. How do you find fh? Okay, fh is there, we need fh. So this last question, so let me clear down here, take it down a little, and delete. I think this space will be enough for the last question, but let's also clear inside. Right, let's now go back to the question. So what are they saying? They want to give us an answer, then bafuna a solution. A solution that leads right to the answer they've given us. So what they're saying is that given that fp, okay, let us clear up, we have a lot of circles on the drawing. Okay, okay, given that fp, the distance from there to there, that vector is equal to k times fh, vector fh. All right, so let us write that down. So fp, we're told, is equal to k times vector fh. Show that vector ep is equal to this answer here. So the first thing we're going to do is we're going to find the value for fp. So the k here is acting as a scalar. Remember, in the last session we looked at scalar quantities, right? So we're going to say vector fp will be equal to k times the value for vector fh. So what is fh? So remember, we said instead of capturing this one, we capture the expanded one. So fh is basically 4 vector a minus 4 vector b. When we simplify that one, what do we get? We're going to say fp will therefore be equal to, so k times 4a, it will be 4k vector a. So when you're dealing with vectors, you always start by writing the variable before you write the vector. So the k here is a variable, and then the a is a vector. Okay, again, k times negative 4 vector b, that will give us negative 4. We write the variable k, and then we put the vector at the end. So this is the value for vector fp. Now let us look at the question. What they're asking us to find, we need to show that vector EP. Okay, where is E? E is right there. P, okay, is equal to that answer they have given us right here. So how can you find vector EP? So remember we have FP. So we can simply go from E direct to F up here. Let me erase the values. Remember we know the vector here. It is the answer from finding down here. Okay. So meaning we can move from E to F and then from F to P. So that's how we're going to find vector EP. Okay. I think we can now clear space here. We don't need this other guy. I've already captured the answer. Let's just create space there. Okay, so I'm now going to say vector EP. Let's switch to my pen. But let me clear up here. So I'm trying to find vector EP. So I'm going to move from E to F. So EF, vector EF plus, and then we're going to move from F to P. Okay, plus FP. Let me plug in the values for those vectors. So EP, vector EP is equal to, what is EF? EF is positive 4, vector B there. We're heading the same direction as the vector. Okay, and then what is FP? FP is the answer we found down here. Okay, which is plus 4 K vector A, is it, minus 4 K vector B. All right, so now have it in mind that this is where you're supposed to land. This is the answer you're supposed to find down here. Okay, so you notice to say 4 K vector A is right at the beginning, and you notice it has no like, there are no like terms that have this variable K, the variable A. Okay, but these two are like terms. So meaning this guy, the 4K vector A, which is appearing in our final answer here. Compare with what you, as you are solving, compare what you are finding with the final answer. Okay, so the final answer is starting with 4K vector A. So we're going to say EP is going to be equal to, we bring this guy to the front, the 4K vector A there. And then we're going to group the like terms. The 4 vector B and the 4K vector B are like terms because they have a B in common. So we're going to say the 4 vector B is a positive, so 4 vector B, they have some like terms. They're not entirely like terms, they just have a 4 and a B in common. So 4K vector B. Alright, then we're going to say EP vector EP is going to be equal to 4. We have already established that this guy is supposed to be right here. So we'll simply rewrite it the way it's appearing. And then now you notice to say, here, what did they do? There's a 4 on the left and then there's a B on the right. If you compare these values here, you notice to say what are the like terms. The 4 is common and the vector B is common here. There's a 4 there, there's a vector B here. So all they did was, Mr. Emmanuel, you remember this? We did these types of factorization in first year, the time we had mathematics at uni. Okay, so here they factorized on the left side, they factorized with a 4. Okay, and then on the right side, they factorized with a vector B. Right, so instead of us saying 4 vector B as the common factor, we are moving the B to the other side of the bracket. Okay, this side. All right, but as we're factorizing, we're having it in mind that we're factorizing with 4 vector B. So that's how come we're going to say 4 vector B divided by 4 vector B there, it will just give us a 1 inside here. Okay, that is the one you are seeing down here on your answer. Okay, and then here we have a negative, so negative divided by a positive there is a negative. Okay, let me clear up these arrows again. We're remaining with one term to factorize. Okay, so you can simply say again 4 divided by this 4 here, it gives you K. Okay, and then the vector B and the vector B will cancel. So that's how come your final answer, let me write it properly, it's going to be equal to 4 k vector A minus or plus actually 4 open bracket 1, right, minus k close bracket vector B. Okay, and now when you check, this answer is exactly as what you have right here in the question. So the only thing you need to take note of is that sometimes when you are factorizing, on the left side you can place the coefficient, and then on the right side you place the vector. All right, that is the only new thing about this type of factorization. Or sometimes they might switch the coefficient, they put it on the right, and then on the left they put a vector. So that is basically how you are supposed to show that that is the final answer, and at the end you again write hence shown. So you're going to say hence shown, then you indicate the answer, hence shown. Okay, so that is all I had for you on vectors. Do you have any questions at this point? If you're panga sense, please give me some thumbs up. That way I will know to say people have understood and are ready for some assignments. Okay, let's see. All right, if we understood, that is good to hear. So now here's the thing. Vectors can be a tricky question sometimes. How do you make it to be less tricky? You practice it. All right, so even these examples were from doing in the videos. You can actually capture them and then you practice them. Since you already have answers, you can refer to the video for the actual answers. So if you practice these examples, because again, if you've noticed, we cover a lot of questions in our assignments. There are times I have less questions to give to you as assignments, because remember the scope is from 2025 to 2016, roughly 2017, because 2016 those are the what do they call the specimen they gave us, and the exams for the internal and the external, they have like sort of been outdated because the format has somewhat changed over the years. If you compare most of those questions like from 2016, both for the grade 12s and the GCE, you even find questions such as on simultaneous equations. Those questions no longer come. So the best way is you can start revising from as far back as 2017 up to 2025. So you notice sometimes we cover a lot of questions to a point whereby, as I'm giving you these assignments, you find that I don't have enough questions to give you as assignments, because some of them we covered them during the lessons as we are learning. So it simply means for practice purposes, also practice the examples we look at in the lessons as well. Okay, that will help you be able to make sure that you cement your knowledge on that particular topic. Don't just focus on the assignments, also try to do the questions that we are going to be covering in the lessons. Yeah, because we have a limited number of questions, and for the fact that we're using exam questions as examples, the idea is we need to cover as many exam papers as possible. By so doing, you would have figured out to say, this is actually how this question comes. So you notice the first part of the lesson, there was nothing like show that this is the final answer, show that when you solve this particular vector, this is what you're going to get. Some of those questions did not have this type of a question at the end, but for these types of questions, they had something like this. So otherwise, this is all you need to know about vectors. This is a very, very simple topic. Please just practice it. When you practice it, it will start making sense. I'm recording this video, so I'll share the recording. If you need to rewatch it, please rewatch it and make sure you get it right. I need you to be able to answer everything in section A. Okay, you need to be safe, so please aim for everything in section A. When you answer everything in section A, paper 2, you are getting safer and you're getting nearer to getting that distinction 1 that you want. So please revise these questions. That's how it's going to become easy for you to figure them out, in case even the examiner tries to bring something new from what you have been covering. Yeah, so otherwise that is that. On Sunday, another reminder is that we are going to start looking at construction. So please note that don't have mathematical sets, proper mathematical sets. Make sure that by Sunday you acquire those mathematical sets. And you are also required to be revising section A, paper 2, because on what day is that? On Tuesday, should be Tuesday. Okay, either Tuesday or Wednesday, we're going to have a test based on paper 2, section A, the entirety of section A. That is going to be the scope of our test. So please revise everything we have covered. There are certain questions we covered in paper 1, like The ones on coordinate geometry, how to find the equation of the normal to the curve, how to find the equation of the tangent to the curve, how to find maybe the gradient function, all those questions, we covered them in paper at the time we're looking at paper 1. So please start revising those. They like popping up in section A. Okay, so all those are going to come. Otherwise, that is all I had for you in this session. Thank you for making time, and I'll see you in the group as I get to share the assignment.